So moving on to question 9 here, we have a question on logarithms, and we're given that a is bigger than b, which is bigger than 0, or both are bigger than 0, and that a and b both satisfy this equation here. We're asked to show that a is equal to b squared divided by b minus 1. So, question on logarithms, so you've got to be confident with your properties and rules of logs. So let's have a look at tackle it, see if we can show that this is equal to this. So, where do we begin? So, this is a equals, and this is log a minus log b is equal to log of a minus b. Well, notice that this is a equals, we've got an a here. So at some point I'm going to want to anti-log. That's a little trick you have to spot. So if I make this log a, oops, so if I make this log a, right, so log a, well what I can do is take this minus log b onto the other side. So log plus log b, like so. Can I use any property of logs here? Well, yeah, of course I can, right? I can write this right-hand side now as a product of logarithms. So, writing it as a single logarithm, that's going to be log of a minus b times b. So, that's my right-hand side now, using the product rule. What I want to do now is look at anti-logging this. So, all that would happen is because logs are on both sides, the equal bases, we can anti-log. So this is going to be a is equal to a minus b times b times b. Now, all I'm going to do is just expand this right hand side. Notice we're getting pretty close to this. We've got a equals, we've just got to manipulate a little bit more to get it into this required form. So a is going to be equal to a times b, so ab, minus b squared. So again, we've got the b squared here, but we've got a minus b squared here. So first thing I'm going to do is I'm going to take this b squared across to this side and take this a across to this side. So b squared is going to be equal to ab minus a, like so. And then let's have a look at factorising. So b squared is equal to a times b minus 1. And notice this is with there. Now we've done all the hard work. Let's put it in the required form. Therefore a is equal to b squared divided by this b minus 1 here. And there we have it. B squared divided by b minus 1. We've got it. 3 marks in the back. Nice and easy. So let's have a look at part B as well. So this is a 2 marker. And it says, write down the full restriction on the value of b, explaining the reason for this restriction. So you can sort of just go step by step with this. Have a look at what we've got here. So we've got a is equal to b squared divided by b minus 1. So the first thing to know is that clearly b cannot be equal to 1. Because this would cause us to have a denominator of 0, 1 minus 1 is 0, and we do not like that. So that's the first thing we can know. We're given that a is bigger than b, which is bigger than 0, so both a and b are bigger than 0. Well, what we can know is that b squared is always positive. If you square a number, it will always be positive. So b squared is positive. So if b squared is positive, what we can then know is that this right hand side here, this b squared divided by b minus 1, must be bigger than 0, because a and b are both bigger than 0 as well. So b squared divided by b minus 1 must be bigger than 0. So the last thing to know is that if b can't be equal to 1 and both a and b are bigger than 0, then b must be greater than 1. So therefore, what this implies is that b must be greater than 1. So we're just looking at this right hand side here and breaking it down logically. You know, we can't have a b value of 1, it causes us to have a denominator of 0. B squared must always be positive, so if b squared is always positive, that implies that this is always going to be greater than 0. And then finally, if b can't be equal to 1, then, and a and b are both bigger than 0 anyway, then b must be greater than 1. And because this is a equals, then it follows as well. So there we go. B must be greater than 1. That's the restriction that is required.